Welcome to this deep dive into JavaScript's event loop, a pivotal concept that powers the asynchronous magic behind modern web applications. In a world where user expectations for speed and interactivity grow daily, understanding the event loop is not just beneficial, it's essential. Today, we'll unravel how JavaScript, despite being single-threaded, manages to juggle multiple tasks seamlessly, ensuring that your applications remain responsive and efficient. Whether you're building a real-time chat application, an engaging game, or a robust server-side solution with Node.js, mastering the event loop will empower you to optimize performance and enhance user experiences. Let's embark on this journey to explore the intricacies of event loop concurrency and optimization. Let's begin by understanding the single-threaded nature of JavaScript. Imagine a single-lane road where cars, representing tasks, can only pass one at a time. This is how JavaScript operates, executing one command after another. However, the brilliance of JavaScript lies in its ability to simulate multiple lanes through the event loop, which is akin to a sophisticated traffic management system. The call stack is where JavaScript keeps track of function calls, much like a to-do list. Functions are added to this list and executed sequentially. When it comes to asynchronous operations like timers, network requests, or DOM events, the event loop steps in. These operations are placed in a message queue, waiting for their turn to be processed once the call stack is clear. Promises, akin to tasks you promise to complete soon, add another layer. When resolved, they trigger microtasks, which are prioritized over the message queue. This ensures high-priority tasks are handled swiftly. In real-world applications, this mechanism is crucial for maintaining smooth performance, especially in scenarios demanding high responsiveness and minimal latency. Yet, challenges such as blocking operations and complex debugging arise, requiring developers to strategically manage task execution to avoid bottlenecks. To illustrate these concepts, let's walk through a practical example using a simple React application. This app highlights how the event loop and asynchronous operations work in tandem to deliver a fluid user experience. Let's take a look at the contents of one of our key files, app.js. Now, let's see the event loop in action within this React application. Initially, the app displays a count of 0 and an empty message. When the button is clicked, it triggers an asynchronous promise, logging microtask promise resolved. This showcases the microtask queue at work, prioritizing this task before other message queue tasks. Meanwhile, a setTimeout function waits 2 seconds before updating the displayed message asynchronously. This simulates a real-world scenario where tasks like network requests or data fetching occur without freezing the UI, maintaining a responsive experience. As you interact with the button, notice how count increments instantly while the asynchronous message updates with a slight delay, demonstrating the event loop's efficiency. In conclusion, understanding the JavaScript event loop is a cornerstone skill for developers aiming to create high-performing web applications. By effectively managing asynchronous operations, you ensure that your applications remain responsive and resource efficient. Whether you're developing client-side interfaces or server-side logic with Node.js, mastering the event loop empowers you to meet the demands of modern digital experiences. As you continue to develop your skills, remember to experiment with different asynchronous patterns and observe their impact on application performance. Thank you for joining this exploration of JavaScript's event loop. Keep coding, keep optimizing, and let's build amazing experiences together.